last time we were talking about using the order of operations to correctly simplify numerical expressions. So purely numerical expressions, that is, we didn't really have any example problems that had variables as well as numbers, but we sort of need to prepare our minds to be working with variables. So we're going to get into that a little bit today. So let me go ahead and share my document camera so we can get the show on the road. Okay. So last time we were talking about order of operations, but section R2, again, this is corresponding to the section in the ebook. Chapter R is a review chapter. R2 is all about simplifying algebraic expressions. And remember, algebraic expressions, the definition that I provided to you guys last time was that it's just an expression or a statement in mathematics that combines numbers, variables, and arithmetic operations. And we looked at, what happens when we have sort of a jumbled mess of operations where it's not just addition and subtraction. We might be combining grouping symbols, exponents, addition, subtraction, multiplication, and division in a jumbled way. And then we have to figure out what is the order in which we need to sort of resolve each of the sort of miniature problems so that we can simplify the entire expression down to a single value. We call that evaluating. So when you evaluate an expression, that is, you simplify the expression. And here I'm sort of avoiding using the word solve, even though you might in your own head say solve. I'm going to save the word solve for when we actually start working with equations. But right now we're just looking at expressions. We need to simplify, if I could spell, the expression until all you have is a single numeric term at the end. Okay, so if we're given an example of a numeric expression, we can just jump straight into GEMDOS, use our order of operations to work that thing down, and then work it all the way down until we just have one number at the end, and we're going to call that our answer for whatever the problem when they ask us to evaluate that expression. So let me go ahead and grab my textbook so we can do some examples just to refresh. Page 12. Okay, so let's take a look at these. We have 8 plus 6 in parentheses divided by 7 times 3 minus 6. Okay. So let's take a moment to sort of think through this and talk out loud to see, what is the first step that we have to do here to start simplifying this expression? What is the first operation that we need to be paying attention to?
Parentheses.
Yeah, we need to do the parentheses first. So I like to always write GEMDOS down just to guide me. And we need to do the G first, which is the grouping symbols. And in this case, it's parentheses. And so our roadmap will be, we'll work on the parentheses. Are there any exponents? Well, no. There's multiplication and division. And whenever we have multiplication and division, those have the same priority. So we need to do those from left to right. And then it looks like we have some subtraction. So that subtraction should definitely go last. Okay, so that's our game plan. We should simplify this term here. 8 plus 6 is sort of like 7 plus 7, right? That should be 14. So I'm going to just simplify one piece at a time, taking care of the parentheses. And then I'm going to bring everything down and keep this in an orderly fashion. You don't want to jump in and do multiple things in one step, because that's an easy way to sort of mix yourself up and then make mistakes. So let's just take our time. We'll get faster at writing things down, but we really want to be paying attention to the details here. Okay, so now we have division, multiplication, and subtraction. And since multiplication and division have the same priority, we have to do those from left to right. And so in this case, the division is going to come first, since that's what is prescribed by our order of operations. So 14 divided by 7 should be 2. We can bring everything else down. And we're just working one operation at a time. So now multiplication has a higher priority than subtraction, so we'll take care of that. We have 6 minus 6 now. And our final answer is 0. So we have evaluated that really sort of cumbersome expression into its true name. Its simplified form is just 0. Anybody have any questions about that? Or any comments or concerns? Seem pretty straightforward. Okay. Well, let's take a look at another one. What if we had something that looked like 4 plus 3 squared all over 6 minus 5 times 3? Okay, I'm going to write GEMDOS just to guide us. And then let's come up with a game plan. What is the first operation that we need to take care of here?
Exponent.
Yeah, we can take care of the exponent first for sure. But what I want to draw your attention to is the fact that this expression sort of looks like a complicated fraction, right? Since we have a fraction bar running through the middle of the problem. So when we talk about G instead of P, I mentioned that there were different kinds of grouping symbols, and fraction bars group different expressions on the top, the numerator and denominator, group them separately. So we can think of this top stuff being grouped together and work that out first, and then work out the stuff that's grouped together on the bottom as its own sort of algebraic expression. Okay, and it doesn't matter whether we work the top first or the bottom first, but we're going to do the stuff in the grouping symbols, stuff that is separated by the fraction bar. And so if we want to start with the exponents, let's go ahead and just simplify the stuff that's on top of the fraction first. So the top part, or the numerator, we're first going to start with the exponents. And we know that 3 squared is what?
9.
Yeah. Okay. And then we can go ahead and do the addition after that, which in that case will be 4 plus 9, right? Which is 13. So if you needed to sort of write that in separate steps, I'm going to draw a little arrow here. That's an arrow. And I could just write this as 4 plus 9, since we took care of the exponent first. I'm going to leave everything on the bottom as it is. And then we can take care of the addition on top and turn that into 13 over 6 minus 5 times 3. And so this is just a way to keep us in order. It's a lot of writing for sure, but if you start hopping around on the top and bottom and you're not sure what you're doing, you're going to lose track of the order of operations that's correct, and you may make a mistake. Okay, so we've taken care of the top part of our fraction. Now we need to take care of the bottom part. So which operation should we do first down here?
Multiplication.
Multiplication. So we're going to multiply. And how do you want to multiply this out? Do you want to multiply 5 times 3 and leave the subtraction sign? Or do you want to treat this as -5 and multiply that by 3?
Oh, 5 times 3.
Does that seem more simple? Yeah, let's just do
Negative 5 and then multiply by 3.
It honestly doesn't matter. You can see it both ways and you'll get the same answer. So if we choose to just take this as a positive 5 times 3, we need to keep that negative sign and bring it down in the next step. So if you don't use it, it gets dropped down to the next step. So we'll just put this is 15, and we'll just multiply this. So that's 15 right there. If you had chosen to use the negative 5 times 3, you would have gotten a negative 15. And since you used the subtraction symbol, you would have to put plus negative 15, which is a little bit more cumbersome because that's just subtracting 15 anyway. So let's just treat these as whole positive numbers and just drag down that negative sign or the minus sign. Okay. So then we just have subtraction left, so we can take care of that. So what is 6 minus 15?
-9.
That seems right to me. -9. Cool. Now, I don't expect you to do all of this sort of side work over here. A lot of this stuff you'll do in your head, but I do recommend that you write some sort of game plan so that you don't lose track of what you're doing or what operations have higher priority. This fraction cannot be reduced since 13 is prime. 9 has only the factors of 3 times 3. So if you wanted to sort of ask yourself, can we simplify? You might say, this is 13 over 3 times 3. And we've done our prime factorization. We see that there is no factor of 3 on the top of this fraction, so we cannot cancel common factors. So we just have to leave it as it is. One note about this answer, though, it doesn't matter when you have a positive number divided by a negative number, where this negative sign is. So instead of having it on the bottom of the fraction, it is just custom to put that negative in front of the fraction and just call this 13 over 9. So negative 13 over 9 will be the final answer. We have simplified our expression. Does anybody have any questions? Again, one note is that negative 13 over 9 with the negative on top is the same thing as 13 over negative 9 is the same thing as the negative in front of the fraction, 13 over 9. These all mean the same thing. Any questions about the note or this problem as we worked it out? Cool. We're just flying through this stuff. Let's look at another example. 3. -3 to the third power plus -5 all over 2 times -8 minus 5 times 3. So I'll give you guys about 2 to 3 minutes to try to solve this by yourself, but let's just write GEMDOS. And I just slipped up and said solve. We're simplifying this expression. Go ahead and take a few moments to try to simplify this on your own. And when you think you have an answer, you can go ahead and throw it in the chat. It seems we have our first proposed answer for simplifying this expression. Anybody have any questions, or is anybody stuck anywhere?
I've got a question. I missed the last one. I came in a little late. What is that negative subtraction sign at the top one to the left? Next to the -3?
To the left, negative.
Yeah.
This is negative, and then this is -3 to the third power.
Doesn't that make it a positive, sir? Because it's times
Not necessarily.
twice.
Not necessarily. You sort of have to go through the order of operations in order to figure it out, whether it's going to be negative or positive.
Ah, okay.
Because this negative sign in front of this term is like multiplication. It's like multiplying by -1. But if you do
Oh, okay.
negative times negative and get a positive, well, you sort of skipped the exponent. You have to do exponents before multiplication. So just be careful with that as you sort of simplify this problem.
Okay, thank you.
Yeah. Because sometimes that order will mess up your overall simplification process. So does anybody else have a proposed simplified, single number answer for this problem? Okay, well, I'm going to go ahead and jump in. If you're still working on it diligently, go ahead and continue doing that. But I'm just going to sort of narrate as I walk through the process in my head. And I'm going to sort of whip through some of the arithmetic in my head quickly. But if you need me to slow down, just unmute yourself and ask me a question, okay? So in my head, I'm going to go ahead and take care of the top part of the fraction first. And for the numerator, what I would do here is take care of the exponent first. Then I would multiply whatever this term over here becomes with this -1. So multiply by -1 here, because that's what that extra negative sign is telling you to do. And then finally, whatever I get over here, I can add it to the -5 that's back here. For the bottom portion, the denominator, I can take care of this multiplication and then this multiplication separately and then subtract them. So I'm going to go ahead and multiply. And then I'm going to go ahead and subtract whatever I get after I do my multiplication. So I'm sort of going to take care of some things simultaneously, but the first step should definitely be taking care of that exponent. So if I took care of that exponent and that exponent alone, then we would have -3 times -3 times -3. So 3 times 3 times 3 is 27. But a negative times a negative times a negative should be -27. Okay. Since that's a negative number, just to clarify, I'm going to put parentheses around that negative number so that I don't get it confused with this negative that I have not used yet. So I'm going to put this negative out here because I have not used it. And then I'm going to bring everything else down. I'm sort of going to work the top and the bottom simultaneously. And so for the bottom, I said I wanted to work the multiplication first. So let's just go ahead and take care of that as well. 2 times -8 should be -16. And then 5 times 3 is 15. So this is -15 there. Okay. So I've taken care of my exponent, and then I've sort of simultaneously done the multiplication on the bottom. Because they're in separate groups, I can sort of do them simultaneously. But now if I want to sort of work the top a little bit more, what I need to do is take care of this multiplication. And so we sort of have to identify this as being -1 times -27, which will turn that into a positive 27 on top plus -5 over -16 minus 15. Okay, so I've taken care of the multiplication. Again, I can take care of the addition and subtraction simultaneous because they're in two separate groups. So if we took care of the addition on top, what is 27 plus -5? Does anybody know?
$22.
Yeah, I mean, it's just easier to think about it as 27 minus 5, right? So that's 22 on top. And then can anybody tell me what -16 minus 15 is? Let's go ahead and work the bottom part.
-31.
Yeah. Yeah. -31. Is everybody okay with that? Does anybody have any issues with subtracting these numbers? If you're not sure, you can throw it into your calculator. But just know that your calculator is not going to do the thinking for you. And if you type something into the calculator wrong, it will not magically give you the right answer. So you have to know exactly what you're putting into the calculator and why you're putting into the calculator. So in this case, it's pretty safe. You're going to put your -16 minus your 15. Be careful because most calculators have a different button for the negative symbol as they do for the subtraction symbol for whatever reason. And we should get that -31 for our denominator. Since our answer is a fraction, we're not going to divide this out and then get a decimal answer. We want to keep our answer as a fraction, but we want to simplify it if possible. So can we simplify this? Well, we, in our heads or maybe off to the side in some scratch paper, we do our prime factorization trees. We find that 22 is 2 times 11, and we find that 31 is prime. So there's no common factors here. So we can just go ahead and leave our final answer as -22 over 31 and call that a day. Does anybody have any questions?
Yeah, on the -16,
Minus 15?
minus 15, you added it? Oh, okay, I see what I did wrong. I treated the 15 as a negative.
What do you mean that you treated it as a negative?
No.
Just to clarify.
No, I messed up off the bat on the portion where I was supposed to add 27 plus -5. And
Okay,
then- yeah, I messed up off the bat right there, and then on the low end.
Yeah.
so -16. So is it -16 minus 15? You got -31, not
Yes.
not -1.
yeah, exactly.
That's what I got -1 on that.
So in your mind, you probably are thinking of 16 minus 15 being 1. But when you're talking about negative numbers, it's better probably to just think about money. Let's say that my bank account is overdrawn $16. I owe the bank $16, so I'm in the hole, -16, right?
Right.
And then I spend $15 on my debit card that I didn't have. So what should my bank statement be at the end of that transaction?
-31.
Yeah, I should owe a lot more to the bank. So if I spend money that I didn't have, I should owe a larger number.
Gotcha. Yeah, I should have took more time.
Yeah, and that's a common mistake that people make. You have to think about it like, I mean, there really isn't a whole lot of time to do this when we start getting into more complicated problems. But if you think about like the number line, 0 is over here, and then we have, let's say -16 is right there on the left side of 0, right? This is where all our negative numbers live. When you subtract, this is back to the grade school days, you should be walking backwards or in the negative direction. So we'd walk 15 spaces this way, so -15, and then we would land on a larger negative number, which would be -31. So that's sort of like graphical representation of that subtraction. So you need to be very careful, not just you, but you in general, like all of you. If it is in your head that, 16 minus 15 should be 1, and that's just the way it always is, and you're sort of neglecting what the rules are for negative numbers, the negative numbers exist. If you're subtracting, the number gets smaller in a technical sense, but it looks bigger. And actually, that's a great segue to this next section that we need to talk about. We need to talk about a concept called absolute value. Perfect segue, actually. So absolute value, the absolute value of a number, measures the distance a number is from 0 on the number line. And hopefully this will clear up some of these ideas about addition and subtraction with positive and negative numbers. Okay. So let's think about a number line. Well, let me say this first. The absolute value has a symbol when we have these vertical bars around a number, and I know that this isn't a number, I'm using a variable here. This statement here is read as the absolute value of x, whatever that number will be, given whichever problem. Okay, so for example, if I gave you the absolute value of 3, and I just asked you to evaluate it, or asked you the absolute value of 3 is equal to what? Well, you would have to remember what the definition of the absolute value is, which is it measures the distance of a number from 0 on the number line. So this is like asking how many units away from 0 is the number 3? So if you needed to, you could draw a number line, put 0 in the middle, negative infinity is on the left-hand side, positive infinity is on the right-hand side. And we could just walk to the number 3, right? 1, 2, 3. each of these tick marks is 1 unit. And you can think of the entire numbered line is built of just adding 1 or subtracting 1, right? If I just add 1 to 0, I get to the number 1. If I then add 1 to that, I get to the number 2, and so on. So we're just taking steps in increments of 1, which is why we call them units. Okay. If we take increments of 1 to the left direction, we'd be like taking away 1. So we'd get to -1. And if you do -1 minus 1, you get to -2. And if you take away another 1, you get to -3. Okay. But again, the question at hand is, what is the absolute value of 3? How far away in terms of units is 3 from 0? Well, how many steps did we take to get to 3?
3.
Yeah, it's not a trick question, right? We took 3 steps to get to 3. That's why it's 3. Okay, so the absolute value of 3 is equal to 3. Does that seem strange? Does it seem like so simple that like, why are we even talking about it? Okay, well, maybe let me ask you a different question. What is the absolute value of -3? Or in other words, how many units do I have to walk from 0 to get to -3?
-3.
Well, you're close. It turns out that absolute value is only measured in positive units.
That was a trick question.
Yeah. And I want you to think about it this way. Whenever we make any measurement of length or distance in the real world, let's say that you're measuring a 2x4 because you're doing some framing on a construction site. You're gonna put up a shed, or you're gonna put up some sort of building, and you needed to measure 3 feet from some sort of like post. Okay. Well, you could measure, let's say that you needed to measure 3 feet on each side of the post. You would pull out your tape measure. You would pull out 3 feet of tape, and then you would just point that in the direction of wherever you needed, this 2x4 to extend to. But on the tape measure, are there any negative units?
No.
Well, I mean,
No.
I guess if you don't have any experience with a tape measure, you don't know. But like, you're not going to take the tape measure. Oh my Lord, I have a tape measure. You're not going to take the tape measure and then push the tape back into the tape measure. Nobody can see this because of the, you don't push the tape back in and then it comes out the back and you get negative units magically. You're just going to pull the tape measure out, and then you're going to put it in the direction, either positive or negative. So absolute value is just a positive measurement of distance from 0. So it doesn't matter what direction. This -3, if we're asking how far away is it from 0, we're just going to say it's 3 units. And it's always going to be a positive measurement. So -3 is out here on our number line. We had to walk 1, 2, 3 units to get there. That's our distance. So what we'll write down is that the absolute value of -3 is equal to +3 units. Does anybody have any questions about that? Okay. So the reason why we introduced this operation really, because it's both an operation that we're performing. We're taking sort of any number that we're given and we're just turning it into a positive measurement as a distance from zero. Because absolute value is going to be thrown into the mix here with some of these order of operation problems, these numerical expressions that we're going to need to simplify. So let's take a look at some examples where we're going to simplify some expressions using order of operations, again, using GEMDOS. But now we're going to have some expressions that utilize absolute values. So let's start with this one. -5 plus the absolute value, so these vertical bars, of 7 plus -3 plus 7, and then I'm closing the absolute value bars here. So I'm going to highlight the absolute value bars just to make it very clear that's what this is. That all of this addition is happening inside of the absolute value bars. So can anybody tell me what's the first operation that I have to take care of here? Go ahead and use GEMDOS to guide me.
The one inside the absolute value?
Yeah, exactly. So we need to start with G. Again, absolute value is going to be one of our grouping symbols. It's just a special grouping symbol because once we simplify everything in the absolute value bars, then we're going to take or return the absolute value of whatever that number is. If it's a positive number, then it's going to remain positive. But if it's a negative number, the absolute value bars will spit out the positive distance from zero. Okay. So let's go ahead and simplify everything inside the absolute value bars first. So we can just go ahead and add this straight across because it's just addition. If we needed to, we can sort of break it up into two pieces at a time. 7 plus -3 is the same thing as 7 minus 3. So that's just 4. I'm going to go ahead and bring the absolute values down since I'm only doing these piecewise. I still have some operations to do in there, but I'm just going to go ahead and write down everything I have left over. And now I still have this grouping symbol here. I haven't used the absolute value symbol yet, but I have 4 plus 7 in there. So I'll go ahead and resolve that. 4 plus 7 should be 11. And so I'm going to put 11 with these fancy little flags on it so that you don't confuse it for the two vertical lines here. Okay, going to bring the plus and the -5 down. So I've simplified everything that was in the absolute value bars. And now I can actually take the absolute value of positive 11. So can anybody tell me what the distance is in terms of positive units? How far is 11 from 0?
11.
Yeah, it's just 11. So this, we can just drop the absolute value bars in some sense and just write down 11 plus our -5 that's out here in front. So now all we have to do is take care of the addition. What is -5 plus 11?
6.
Yeah, it's just positive 6. You can think about that like money. Again, I always like to bring up the example of, I just don't know how to manage my money. I have -$5 in my bank account, and then I deposit or I come into $11. Well, I owed the bank $5, so they're going to take that right off the top. And all I have left is the positive $6. So that is the expression. We've simplified it. 6 is the answer. Anybody have any questions?
No, sir.
Cool. Let's see. I got some more examples for you guys with absolute values.
Sir, on one of the homeworks, there was There was an expression that I had to research online. But simply it asks that we flip the number, for better lack of words. So I forgot the terminology. I should have wrote it down. But for example, let's say the number is 19, right? And we know that as a fraction, 19 equals 19 over 1, right?
Yeah.
Okay. Well, this terminology that was utilized on the homework basically asked us to now flip it to 119, and that was all it was.
1 over 19. Yeah, I was asking for the reciprocal.
Reciprocal, right? Okay, there's the word. What is the purpose of that? I know I was getting off the topic, but it was in my mind and it just came to me.
Yeah. Those problems will only, we practiced flipping a fraction when we were doing what operation? When we were dividing fractions. I said that the algorithm or the method we're going to use is keep, switch, flip. When you
Yes.
flip that second fraction, that is called flipping it to its reciprocal.
Okay.
So when you divide fractions, you multiply it by its reciprocal and you get the same result.
Gotcha.
So I may not have been very particular about like emphasizing that terminology, but that's what that means. And so those problems in the homework, we're just getting you to like figure out, given a fraction or given a number, what is its reciprocal, so that when you come across dividing fractions, you would know what to do.
Okay, understood. Yeah, because I was looking at my notes and I didn't find that defined, and I was like, well, all right, I didn't see the purpose in it, but I do understand the keep, switch, flip now.
Yeah.
Okay.
So that's just the terminology that we call that second fraction, what we're doing by flipping it.
Reciprocal.
So
Okay.
dividing by a fraction is the same thing as multiplying by its reciprocal.
Gotcha. Thank you, sir.
So let me just go ahead and make up a problem for us. So 5 plus negative 2/3, the absolute value of that, plus negative, let's go with 3/7. Okay. So can anybody tell me what's the first operation that we need to take care of here?
The absolute value?
Well, we need to do the stuff that's inside the absolute value, right? So I'm just being a little bit nitpicky with the phrasing, right? Because we want to process the stuff that's inside the grouping symbol. And then once we've resolved all that stuff that's inside the absolute value bars, then if that's a positive or negative number, we're going to have to take the absolute value and then spit that out. So let's do it, right? We need to do this fraction operation that I've given us. So this stuff on the inside, we'll focus on, we'll sort of ignore all the other stuff so that it doesn't cloud our judgment. If I am adding negative 2/3 plus negative 3/7, what do I need to do to these fractions in order to add them?
You have to find the greatest common factor.
The least.
No.
Denominator,
You
right?
have to make the denominator the same. Denominator the same.
Find the least common denominator, not the greatest common factor.
Sorry.
Yeah. So it's very confusing because, I mean, there are 3-word phrases that sort of describe similar concepts. And you can sort of find each of them by using prime factorization if you wanted to. But again, we need to make these denominators be the same. That's the gist of what we need to do here. Otherwise, we're trading pizzas that have different size slices, and we want to make fair trades. So we need to get the same slice size. So the trick that I gave you guys before was to, take this denominator over here and just multiply it by the first fraction. So 7/7 goes to the first fraction. And then we can take 3 from this denominator and then multiply that over here, 3/3. And the reason why we can do that is because look at the denominator multiplication that we're going to do. 3 times 7 on this side of the problem is going to be the same denominator as 7 times 3. So that's why we do it, because it works to give us the same denominator. We're going to get denominators of 21. And then, the numerators will change, but we have to sort of be we can't be rigid. We have to be flexible with that changing numerator, because as long as the denominator is changing, that's the goal. So now we have 2 times 7, or you can think of it as negative 2 times 7, in which case that will be negative 14 on top here, and negative 3 times 3 over here, which would be negative 9. Well, now we can keep the common denominator, which is 21. And all we need to think about is negative 14 plus negative 9. So can anybody tell me, though, what is negative 14 plus negative 9?
Negative 23.
Yeah. Negative 23. Is anybody confused by that, though? I think it leads to good discussion if people like admit their confusion by that, because it can be confusing. So I like to think of it as, let's say that I have negative $14 in the bank, and my spouse, bless her heart, is in a better place now, but she left me with her $9 of debt as well. And I inherited that $9 of debt. So if I already had $14 of debt, and then I inherited more debt, I should have larger debt. So now I can just go ahead and go over here to 5 plus the absolute value of negative 23 over 21. This fraction does not simplify. For now, and just in the interest of time, you'll have to trust me on that. When we take the absolute value of this negative fraction, again, I have no idea where on the number line negative 23 over 21 lies, but I know that it's a negative number. And if we take out our tape measure and measure the distance to this number, whatever it is, it will be 23 over 21 units from 0. So it's just the absolute value is just gonna spit out the positive version of this fraction. So we should just have 5 plus 23 over 21. Does anybody have any questions about that?
So it won't be negative anymore?
No, because remember, the absolute value is measuring the positive distance. This is asking you, give me the positive distance that this number lies away from 0.
Gotcha.
So it's always going to just like, whatever you get, it's going to spit out a positive version. If
Okay,
it's positive, it goes to positive, stays positive. If it's negative, it goes to positive. A lot of students make the mistake of thinking absolute value switches to the opposite sign. That's not what it does. It measures a positive distance. So it's always going to be spitting out a positive number. Okay. So that being said, now we have a whole number plus a fraction. We need to write them both as fractions with a common denominator in order to do this addition. So let's do that. I'm going to write this as 5 over 1 plus 23 over 21. We're going to trust the process here. If you needed to, we could take this 21, multiply 21 over 21 on this side. We're going to take this 1 and we can multiply 1 over here. Or really, multiplying by 1 on this side isn't going to change anything. The magic that's happening is over here, where now 1 times 21 is going to give us this denominator of 21. And then we need to do 5 times 21. Well, 5 times 20 is 100, so we have an extra 5, right? That should be 105. And I'm just going to double check in the calculator because it never hurts to double check. Yep, 105. Plus 23 over 21, which is equal to, oh my God, 128 over 21. You guys okay with that? And then we sort of have to see if this is, if it can be simplified. So in my head, 21 is 7 times 3. So I just need to check to see if 128 is divisible by either 7 or 3, or both. So I'm just going to take my calculator and quickly just assess, divide this by 3. That didn't work. Didn't get a whole number. 128 divided by 7. That didn't work either. You could try 21, but if 7 and 3 didn't work, then 21 shouldn't work. And it doesn't. So since the factors of 21 don't divide into this number, that means that there are no common factors. So we can say that this fraction is completely simplified. We have solved or simplified our expression entirely. It's this really weird fraction, 128 over 21, but we trust the process even though the result looks a little bit strange. Any questions, comments, or concerns?
Can we do another example?
Yeah. Let's see. Let's look at 2 times the absolute value of -6 minus the absolute value of 3 times 10. All of that over the absolute value of -6 times 10. And just to emphasize the absolute value bars, I'm going to highlight them in orange. So what is the first thing that you guys want to do? You're looking at this problem dumbfounded, maybe. Does anybody know, like, what is the first operation that we need to sort of look at and resolve before we can sort of move on and start processing this thing?
Start working with the absolute values on the top line.
Yeah. So remember, the fraction bar sort of separates the top and the bottom of this expression so that we can work on the top first if we wanted to, or the bottom first. It doesn't matter what order, or we could work on the top simultaneous to working on the bottom. But if we are working on the top expression, then what I would do is we have some work to do inside of this set of absolute values, this one on the right, because we have multiplication inside there. For the other absolute value, we just have a single negative number in there. So there's no operations to do, sort of no work to do inside the grouping symbol. So why not just do the multiplication first? So in the absolute values, absolute value bars, we'll start with the multiplication, multiply. And then once we multiply this out, we'll just have a single number in this absolute value bar, a single number in here. So we can actually take or evaluate the absolute value. I'm gonna put abs value here. And then we can go ahead and do whatever sort of multiplication that we have next. And then we can finalize this with the subtraction, and that will take care of the top. For the bottom part of this, we need to multiply the stuff inside the absolute value bars. So we're going to multiply. And then whatever number we get there, we need to take its absolute value, or return its absolute value, however you want me to phrase that. Okay, so that being said, let's go ahead and multiply this 3 times the 10, and that'll take care of this part. So I'm gonna just resolve that or simplify that and bring everything else down as it's written. So 2 times the absolute value of -6 minus, we still have the absolute value bars, but 3 times 10 is 30. And I'm going to bring everything down. We'll do all the top first, and then we'll worry about the bottom. So -6 times 10 in the absolute value bars. Okay. Anybody have questions there? Well, now we need to take the absolute value bars. We're working on the top. So What is the absolute value of -6?
6.
Yeah, perfect. So we can rewrite this as just 2 times 6 if we wanted to. We're going to take the absolute value of ours, or take the absolute value of -6. And we could take the absolute value of 30. What is the distance that 30 is from 0 on the number line?
30.
Yeah, just 30. No trick question there. Cool. So we've taken the absolute value. Now we can go ahead and multiply. Let me go ahead and write this down. We can multiply the 2 times the 6 and get 12. And then we can, running out of space here a little bit. So I'm just going to draw an arrow, give me a little bit of writing room. Take the 12 minus the 30. So 12 minus 30. What is that, 18? Negative 18?
Yes.
Cool. Negative 18 is remaining on top. So we've done that multiplication and we did the subtraction. So negative 18 is what remains on top. Then we can go ahead and take care of the stuff on the bottom here. And just in the interest of space, I'll sort of do it simultaneous here. -6 times 10 should be -60 on the bottom, but we still have these absolute value bars. Then when we take the absolute value of -60, we should get +60 on the bottom now. So we have -18 over 60. Are we done there though?
No.
What do we have to do next?
Simplify.
Right. So I know that 60 is divisible by 6, and so is 18. So if we didn't want to do prime factorization and we wanted to cut some steps out, we could divide this by 6, divide that by 6. But really, we're dividing out a common factor of 6. And we should get -3 on top, since 3 times 6 gives us the 18. And then we should get a 10 on the bottom here. 10 only has factors of 2 and 5, which won't be in common with our 3 up there. So we know that now our fraction is fully simplified. -3/10 is our answer. Okay. So now I sort of want to change topics a little bit because we haven't talked about this special case for division that we need to be super aware of, because it can pose, division is one of these operations that can pose a lot of problems for us if we are dividing by 0. So you may think you know how to divide, but this is a problem that each semester sort of trips up students. So we need a special note about division. So the definition as mathematicians use or define division is we typically don't use this symbol anymore. We don't use this symbol often in mathematics and algebra and beyond. We write division as a fraction bar. So if I had the expression A over B, that is the same thing as saying A divided by B. Okay. So we're going to have to get used to thinking about these fractions as a division problem. And usually that actually can help us simplify some fractions a little bit more easily. Like if I had 21 over 7, it's easier to think of that as 21 divided by 7 and then simplify that to 3. But the definition of division is that if I have A over B, and that's equal to some number, let's say X, that implies that X times B should give me A. This is the definition of division. And it's a nice definition because it really defines it in terms of multiplication. Now, let me give you a concrete example, because whenever I use nothing but letters or variables, students can often, their eyes glaze over and their eyes roll back into the back of their brains. So let's think about that example that I just gave. Let's say 21 over 7 is equal to 3. That implies that 3 times 7 is equal to 21. So it's like you take this number, multiply it by that number, and you should get this as a result. So there, multiply, and then you get equals. Does that make sense? Right, like 25 divided by 5 is really the same side of the same coin, or a different side of the same coin, is saying that 25 divided by 5 is 5. Although when you start throwing a bunch of numbers out at people, it's sort of hard to catch all of them in your brain. So I totally get that. So let's think about 0 divided by a number. So let's do 0 divided by, somebody give me a number.
7.
Orange.
Well, we're gonna go with 75. What is 0 divided by 75?
0.
0.
Yeah. And that sort of makes sense, because like in our hearts and in our minds, we have this physical interpretation of what it means to divide objects in the real world. If I had 0 cookie cakes from American Cookie, let's say I went to the mall or something, and I had 0 of these cookie cakes to share, and I had 75 friends at a party that I needed to share my 0 cookie cakes with, each of them, if I divided up my cookie cake, would get 0 pieces, because I have nothing to divide, right? And that's how we intuitively make sense of division in the real world. That's the practical application of division. But using this definition, it's still consistent with what mathematicians think of as division, right? Because this implies, let me color coordinate these zeros, right? So this is our 0 here, that's a green 0, and this will be our orange 0. But this statement here, that 0 divided by 75 is equal to 0, implies that this orange 0 times our 75 should equal our green 0. And we sort of have understood since grade school that whenever you multiply something by 0, you get 0. So this makes sense. So we have no problems there. When you have a 0 divided by a number that is consistent with how mathematicians define division. But now there's another case that we'll run into, and that's a number divided by 0. So let's take the number 15, and we'll try to divide it by 0. Can anybody tell me, what is 15 divided by 0?
0.
Is it 0?
Is it undefined?
What does undefined mean? What do you mean by undefined?
Well, I just got an error on my calculator when I attempted to populate that.
Yeah, when you throw it into the calculator, you get an error. We've heard of something called undefined in the past. And some people think that 15 divided by 0 should be 0. Does anybody have any other ideas of what this should be? 15 divided by 0.
Maybe 15.
Maybe 15. Right, and the thought process there is that you have 15 and you're dividing it among 0 people. So you should have like what you started with, right? Sort of using our physical interpretation of what physically dividing something is. Well, we need to be very careful about applying the precise mathematical definition of division here. So if for example, if 15 divided by 0 is 0, which I'm not saying it is, then that implies, and let me go ahead and color coordinate these. This is my green 0. This is my orange 0. Then based on the definition of division that I just gave you, I should be able to multiply my orange 0 here times my green 0 down here, and that should give me 15. But is 0 times 0 15?
No,
Yeah, and it's not. This is inconsistent with our definition. So that means that 15 divided by 0 can't be 0. But then we run into some other problems. So we could say maybe 15 divided by 0 is equal to 15, right? If we think of our physical interpretation and we have 15 slices of pizza or something like that, and we have 15 pizzas and we want to divide that among 0 people, then based on our definition, this implies that our 15 from right here times our 0 from right there should give us 15. But is that consistent either? So that's that's not consistent either with our definition. So that's not right. So it turns out that if we're using this definition strictly, and we need to get whatever this number to be, so let's say 15 over 0 is equal to some number, that implies that we can think of a number x, that when we multiply it by 0, we'll get 15. But if our rule for multiplying by 0 says that anything times 0 should be 0, well, then this is never going to be satisfied. So that's why we say you cannot divide by 0. 0 cannot be at the bottom of a fraction. No division by 0 is possible. There is not a number that you can think of such that a number divided by 0 will return some number. Because the flip side of that is that that number times 0 would have to be something other than 0, which it couldn't possibly be. So that means that whenever we have a number like 15 divided by 0, we're going to say that that is undefined because it literally does not fit the definition of division. Does that make sense?
Yes.
Okay, so in general, if we have, in general, a number divided by 0, and this number is just a, that's going to be my placeholder for a number. Maybe I'll just put any number, negative, positive, doesn't matter. Divided by 0, we're just going to say that that's undefined. So be very careful not to be on autopilot and say, oh, something divided by 0 is 0, because that's not going to be the case. It's not going to be consistent with our definition. And since we're dealing with these sort of complex fractions that sometimes have denominators which might resolve themselves to become 0, once you have 0 as the final denominator of some expression, then you should be very careful in evaluating that numerical expression because it may be undefined. Okay. Next time, we're going to get into simplifying and evaluating expressions with variables. But that's all the time I have with you guys. Time flies when you're having fun. So I hope that you guys have enjoyed today's lecture. It will be posted to Canvas later. So check back in an hour or two. And if you guys have any questions for me or wanted to sort out any confusion, you're more than welcome to stay behind and just chat with me after everybody sort of leaves. But if you have no questions, you guys are free to go. I'll see you next time, same place.
Thank you, Professor.
Yeah, no problem.
I have a question. I always
Sure.
have a question.
Yeah.
Yes, Mr.